How do we plot the reciprocal of a smooth function? So say this is a smooth function, y is equal to fx, and we have to plot the reciprocal function. Let's call that function gx, which is 1 by fx. So first, you know that whenever the value of this function is 0, then fx is 0, then gx will not be defined, right? So at these locations, you will not have the reciprocal function. So there will be poles here. Then you can start taking some points and then analyze these points. So this point here, this is a very small negative output by the function, right? At this location, the output is very slightly negative. So let's say that this is minus 0.01. So the reciprocal function will give you an output minus 0.01, and the reciprocal of that number will be minus 100. So it will be a very big number. So this thing will be reflected here in your reciprocal function. Okay, so if I take a more negative number here, more negative output, like previously we take minus 0.01, so let's now take this is minus 0.1. So if I do that, then I take the reciprocal of this number, that would be minus 10. So it will get less negative. The reciprocal will get less negative. It will be here, right? Before it was minus 100, and then now we have minus 10 here. So similarly, if we take a very small positive number, we will do the reciprocal and we will get a very big positive number, of course. And then if we increase, make the number more positive, then the reciprocal will be less positive. For example, suppose the output here is plus 0.01, the reciprocal will be 100 plus 100, and if the output here is, let's say, plus 0.1, the reciprocal will be plus 10, something like that. So if this increases, that function decreases, and you can then keep on going. So now from here to here, the output of the original function gets less positive, so the output of the reciprocal function will get more positive, right? And then as you start approaching 0, it starts to go towards plus infinity. Then when you approach 0, there is no output for the reciprocal function. Then when you go down, as you are still very close to 0, so the reciprocal will be very big negative number. And then as you get more negative, then the reciprocal will get less negative. And as you hit a minima here, you are hitting a minima here, so there you will hit a maxima for obvious reasons, and then you can go on doing like this. So also this point here where the curve is intersecting the y-axis has no significance, no greater significance. It's just like it's passing through the y-axis. It's okay. The output is something, output is negative, so the reciprocal will get you will get a negative. Also, I will like to talk about, I am thinking that y is equal to 1 is minus 1 is down there, so you have these small numbers here. I will talk about when we get to 1. That is important. So you have this number here and it's smaller than 1, so let's say minus 0.1, and then you get something like minus 10 here. Then you go and then you hit a pole, then you come out of the pole from here, a very small positive number, very big positive number, and so on. It goes on decreasing, and this is where it hits 1. So the reciprocal of 1 will be 1, right? So the output will also be the output of the reciprocal function will also be here, because 1 by 1 is equal to 1. You can also think about like down here, suppose if the function goes like this afterwards, and here you have a point where the output is minus 1, then the reciprocal function will also be crossing like this from this same point, right? So yes, 1 and minus 1 are important that way, and then you can join these lines smoothly and you can get the reciprocal function. Okay, so in terms of derivative, if gx is equal to 1 by fx, the derivative of that function will be this, and what you have to notice here is this part. So it's the derivative of the previous function multiplied by this thing, and this thing can be either not defined if fx becomes 0, or negative because it's a negative number, it's a square, and multiplied by -1. So we are doing real analysis, of course. So it's either not defined or negative. So what does this mean? That the derivative of the reciprocal function is not defined where the parent function has 0. Where fx becomes 0, the derivative of the reciprocal function and also the reciprocal function itself will not be defined, right? So no derivative at that place. Elsewhere, if fx is increasing, then at the same location, its reciprocal will be decreasing, and vice versa, because if fx is positive, then this negative sign here will get multiplied and will make g dash x negative, and vice versa. So you can see all these things happening in the sin x and cosec x graph. This is the green graph is of sin x, and the blue one is of cosec x, 1 by sin x. So you have this point here where sin x has a 0 at minus pi, sin x is 0. So cosec x is not defined at this location. Then you think about this location here, sin x has a value smaller than in magnitude, it's smaller than 1, and it's negative. So you do a reciprocal of that. So then you will see that the value will be even more lesser than -1, and it's increasing here. It's increasing here. So it's decreasing here, right? So how about this? You can reason like that. Same. It's decreasing here. So this is increasing here. So then arises this question: does this mean that whenever fx has a local maxima, 1 by fx will have a minima and vice versa? For example, here you see in the graph of sin x, here you have a maxima, at the same location you have a minima for cosec x. And here you have a minima for sin x, here you have a maxima for cosec x. Is it going to be true always? Well, this is a trick question. Formally not true, but it can be said that it is true. How so? So suppose this is a y is equal to x square, this is y is equal to 1 by x square. Black graph is of y is equal to x square. And you see that it has a minima here. But at the minima, it has a minima at x is equal to 0, right? And at x is equal to 0, f0 is 0. So this is that point where the slope does not get defined, right? This is that place where the slope does not get defined. But if you see more closely, here you have a minima, and this reciprocal function is going up, 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 because this is going down, 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 down. Here also from this side, this is going down, down, down. This is going up, 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 up. But you have hit an infinity there. So maybe if you can think like there is some number like infinity and it's actually getting a maxima up there, but formally it will not be allowed. But you can think of it in this way, that maybe it has a maxima up there at the infinity. Well, another very interesting question is this statement. You have to figure out whether this is true or false. So I am excluding the locations where a function has 0. So I am excluding these locations, because of which we had problems here, right? So formally we can't say there is a maxima of the reciprocal function here. So let's exclude those locations and then think about other locations. If at a certain location fx has a point of inflection, then 1 by fx will also have a point of inflection there. Whether it is true or not, I would like my viewers to answer in the comment section. Thank you.